Welcome to solverfy.
In this exercise, we have an alpha particle that has a charge Q equals to plus 2e that heads towards a gold nucleus that has a charge capital Q equals to plus 79e. And we also have the information that very far away from the nucleus, that is, when r tends to infinity, the kinetic energy K of the alpha particle is 5 megaelectron volts. Okay, and we need to find what is the distance of closest approach that I'm going to call r prime between the alpha particle and the gold nucleus. And in order to do that, I'm going to apply conservation of energy. So I'm going to write the energy when r tends to infinity, okay, is equal to the energy in the distance of closest approach, r prime. Okay, so the total kinetic energy of the alpha particle, the total mechanic energy of the system is given by the kinetic energy of the alpha particle. So this is the kinetic energy of the alpha particle when r goes to infinity, plus the electric potential energy U when r goes to infinity, and this is equal to the kinetic energy at r prime plus the potential energy, the electrostatic potential energy when r equals r prime. Okay. Now, when we know that, I'm gonna write it down here. We know that U, the electrostatic potential energy, is given by K times Q, capital Q, over R. So in our case, this is 158, which is 79 times 2, K E squared divided by R. So notice that this means that the energy, the potential energy when R goes to infinity tends to 0. Okay, and also notice that the kinetic energy in the distance of closest approach, which in the figure is right here, okay, the kinetic energy is 0 because the alpha particle is neither approaching nor going away from the gold nucleus at that specific time. It's still okay. So at that specific time, there's no kinetic energy of the alpha particle, and for that reason, our formula, our conservation of energy equation here that I just pointed to in red, becomes the kinetic energy when r goes to infinity, which is 5 megaelectron volts, is equal to this term here vanishes, and so this term is equal to 158 K E squared over r prime. And we want to find r prime, which is 158 times K E squared divided by 5 times 10 to the 6th electron volts. Okay, one of the electrons here, one of the electron charges cancels out, so we have 158 times K, which is 9 times 10 to the 9th newtons meters squared coulomb squared, divided by 5 times 10 to the 6th volts. Let me just write 5 a little better here. Okay. So what we have is that r prime is equal to 4.5 times 10 to the minus 14 meters. And this is the distance of closest approach.